Let's consider this situation dealing with waves. We have a summary of the two different types of waves in an earthquake, S waves and P waves, some general information, and then some specifics about a given earthquake. So, in a particular earthquake, we have S waves traveling at 3.45 kilometers per second. And P waves traveling at 8 kilometers per second. We also know that the range of the earthquake is 230 kilometers, so that'll go for both of them. So I'll just kind of put that in the middle. And that the period for each wave is 20 seconds. The period, that is the time for one complete wave, and our symbol is a capital T. So now in part A, we're going to calculate the wavelength for both waves, both the P and the S wave. So if we want the wavelength, symbol is lambda. We've got the equation V is equal to wavelength over period. So then plugging in individually for the S wave, that would be 3.45 kilometers per, and I believe that should be seconds there, kilometers per second is equal to lambda over 20 seconds. And we can solve down for lambda for the S waves to be 69,000 meters, converting from kilometers into meters. Then if we plug in same equation, but now for the P waves, so it'll be 8 kilometers per second is equal to lambda over 20 seconds. That's going to give us a lambda for the P waves of 160,000 meters. Part B, calculate the frequency of each wave. Well, if we want the frequency of each wave, considering what we know, frequency and period are inverses of each other. So then frequency is the time or the number of waves in 1 second, and period is the time for one wave. So then we can calculate the frequency for the S waves as 1 divided by 20 seconds. And the frequency for the P wave also is 1 divided by 20 seconds because they both have the same period. So then the frequency for both of these waves would be 0.05, and that would be waves per second, or typically we would write that as hertz. So again, that applies to both of our waves. Now, part C, calculate the time it takes for the S wave to reach a town that is 110 kilometers from the epicenter of the earthquake. So then we've got the epicenter, I'm just going to represent as an E, and then a town over here that is 110 kilometers. This is dealing with the speed and the displacement, so this would be V equals delta x over delta t. We're dealing with specifically the S waves, so we need the velocity of the S waves, 3.45 kilometers per second. Delta x is 110 kilometers, and we want to solve down for the time. So if we do our algebra, putting this over 1, cross multiplying and solve down, we get a time period of 31.88 seconds from when that earthquake starts at the epicenter until it reaches the town 110 kilometers away. Ponder physics.